Advanced Math Lesson 7 is all about reasoning and logic. In Part A, we're talking about different kinds of reasoning and the process of gathering data, making observations, and making guesses in order to try to find a rule. That one is inductive reasoning. Inductive. Whoops. Inductive reasoning. And then deductive reasoning is the process of using a rule once it has been formulated. You already have a rule and then we're using it. Deductive. If the rule is false and we use the rule properly, the conclusion can be false because you started out with something false. We can also reach a false conclusion if we use a rule improperly. The study of logical reasoning is a study of the proper use of the rules, and the truth or falsity of the rule is not a consideration for our purposes. Not a consideration. Okay, just for the purposes of studying logic, it is not a consideration. In real life, it is definitely a consideration. It's important that they are not false. Okay. Part B is just called logic, and we'll be doing a good bit with syllogisms. Okay, so this is something the Greeks used in their study of logic, and it starts out with a major premise, which this says is a non-reversible statement. You'll see a bunch of examples. This is like making a statement often about a group. So making just a broad, generalized statement. And then the minor premise identifies a member of that set, of that group. And then the conclusion is that member that was identified has to have the same property as the one that the whole group has. And again, this sounds very abstract, but you'll see in the examples. So, the major premise is a conditional statement. It can be written as an if-then statement. Even if it doesn't start out as one, you can rewrite it into one. So here we have one about Julie and her goggles. Julie wears goggles when she is swimming. There is no if or then written in that sentence, but we can change it into one. If Julie is swimming, then she's wearing goggles. Then she wears goggles. Okay, so the if part is called the hypothesis. The then part is called the conclusion. Okay, so a major premise can be written into an if-then statement, and the end of that, the then part, is called a conclusion, not to be confused with the conclusion of a syllogism. That's not the same thing. All right, so take a look at this first one down here. Our major premise is, if Julie is swimming, then she wears goggles. Okay, we have it here written as an if-then. The minor premise is Julie is swimming. And the line is here, like, that's always the thing. You have the major premise. It's like the rule. And then the minor premise is identifying one, like, subgroup, or in this case, just, yes, she's swimming. Okay, if the minor premise matches your if, the hypothesis, then you can reach a valid conclusion, and that would be she wears goggles. Okay, so this is a valid argument or a valid syllogism. When the minor premise matches the if, you can reach the conclusion that we have right here. Okay, that is a logical progression. Oops, let's say, okay, so if the minor premise matches hypothesis of the major premise, we can logically conclude with the conclusion of the major premise. And when that happens, we say we have a valid argument. Okay, let's look at this one. There will be a quiz every Wednesday. It is Tuesday. Therefore, there is not a quiz. So, is this valid or invalid? What do you think? Okay, way to make sure, we are going to rewrite that major premise as an if-then. This says, if it's Wednesday, then there's a quiz. Okay, so I'm just going to rewrite it up here. If Wednesday, then quiz. There's my shorthand for it. If Wednesday, then quiz. Okay, so we just said if the minor premise matches the if, then we can reach a conclusion. It's Tuesday does not match if Wednesday, different days. No valid conclusion. This is not valid. Invalid, not invalid. Okay. There's more. All right, so first a note. Please note that it doesn't matter if one or both of the premises are false. Again, in real life, that really, really matters. But to be logical, just for the process of the logic of it, it doesn't matter. Okay, we can still reach a conclusion if the minor premise matches the if of the major premise. Okay, so the following is valid, even though we all know the major premise isn't true. Not all chickens have 3 legs. Most of them have 2. Okay, so this is false, but let's see if this is logical. We're just told here that it is. Okay, so all chickens have 3 legs. So making that into an if-then, we'd say if chicken, then 3 legs. Okay, if chicken, then 3 legs. You don't have to abbreviate so much, but CK is often used for chicken. Okay, so Penny is a chicken. It's identifying this one animal in this case as being part of this group that's being spoken about in the major premise. The minor premise, chicken, matches the if, chicken. So we can reach the conclusion that Penny has 3 legs. That is valid. Okay? Now we get to figure these out. Is this argument valid? Why or why not? Okay. All normal dogs have 4 legs. That dog has 4 legs. Therefore, that dog is normal. Okay? Valid or invalid? We need to rewrite the major premise as an if-then. So, if normal dog, then 4 legs. Okay, so if normal dog, the if's going first. I'm not going to keep writing if and then. If normal dog, and I'm putting an arrow for the then 4 legs. Okay? Normal dog, 4 legs. That dog has 4 legs. Does not match normal dog. Not valid. That's all you have to do. Rewrite that as an if-then. See if this matches that. If it does, then the conclusion would have been 4 legs, but they have them swapped. Invalid. Why or why not? This is identifying it as having 4 legs, not as being a normal dog. Minor premise doesn't match hypothesis. Okay, next one. All boys are good. that child is a good child. Therefore, that child is a boy. Valid or invalid, whether you agree with the major premise or not. Okay, make it an if-then. All boys are good, so if someone's a boy, then they must be good, right? If boy, so I wasn't going to keep writing if and then, but I just wrote an if, so here's my then. If boy, then good. Okay, that child is good. Good and boy are not the same word. Okay, it's identifying that child as being good, but not identifying that child as being a boy. Just because all boys are good doesn't mean some girls aren't. So this is invalid. Same reason as before. I'm not going to write it again right here, but it's the same exact reason as the example above. Not valid because the minor premise is not indicating the same characteristic that we see in the hypothesis. Okay? On to part C, something called the contrapositive. You'll find this quite useful for some of these. And now, just get used to some notation. The major premise is a one-way process. If P, then Q. Okay, that's what the P arrow Q is, and that's what I started doing up above there. The if comes first, the arrow is saying, then here's your conclusion. Then it points to that. So Q is the conclusion. If P, then Q. All right, and here's another one that is not written as an if-then. Rabbits are fast runners. Okay, so we can reword that. If rabbit, then fast. Then fast runner. Okay, the whole sentence is written here. My PQ thing, I would say, if rabbit, then fast runner. Okay, my hypothesis, my conclusion. When we're writing the contrapositive, you take your if-then statement, you negate both the hypothesis and the conclusion of the major premise and you swap them. They change places. I think I'll just write swap them. However you would like to write that, you reverse their order. Okay, and negate means we're going to, if there's already a not in your hypothesis or conclusion, you take it away. And if there wasn't one, you put it in. So for this rabbit being a fast runner, the contrapositive, they have to swap places. So the runner part is going to go into the if position, and we're going to negate it. So if not fast runner, not fast runner, then not rabbit. Okay, I put a negative in each one of them and swap their places. That's the contrapositive. And you'll find the contrapositive, if the major premise is true, the contrapositive will also be true. If the major premise is false, the contrapositive will also be false. It's basically another way of saying the same thing. If it's a rabbit, then it's fast. If it's not fast, it can't be a rabbit. Okay, there's more. All right, is this argument valid? Major premise, all non-athletes are vegetarians. Jim is a non-vegetarian. Therefore, Jim is an athlete. Okay, first, I know the major premise isn't true. I know a lot of non-athletes who are not vegetarians. But we're going to go ahead and change this into an if-then statement. So, if not athlete, that's what a non-athlete, okay, if not athlete, then vegetarian. Okay, so there it is. Now I'm looking, does this match the if? This says not vegetarian, it doesn't say not athlete. So it looks like it's invalid. But now I know about this contrapositive thing. So I'm going to try writing the contrapositive because, like I said, the contrapositive and this major premise are saying the same thing, just in a different way. So now I need to rewrite this. Vegetarian moves to the front, but I put a not with it. Okay, not vegetarian. Then, now athlete goes to the end. And again, to negate it, don't say not an athlete. We're just going to, if there was already a not there, we're taking it away. So athlete. Think of negatives. The opposite of a negative is a positive. So it cancels out that not. Okay, so this is saying the same thing as the first one. If not a vegetarian, then an athlete. Okay? Now, Jim is a non-vegetarian. That means the same thing as not a vegetarian. So he is an athlete. This is valid. Okay, so here was the major premise. Here is the contrapositive. And if our minor premise matches the if of either one of these, it is valid. Okay, we have a valid argument here. All right, part D. Part D is mostly about the converse and the inverse. These are other ways of moving things around or negating them in your major premise. And the first one you see here, the major premise is always if P then Q. This one is if Q then P. That one is the converse. And then if not P, then not Q. That symbol in this context is used for not. If not P, then not Q. That's the inverse. Okay, now even if the major premise is true, not necessarily true, like for the converse and the inverse, they are not necessarily true. Contrapositive, yes. These, no. And this is something to watch out for just in advertising or politics or anything. When someone's trying to influence you to make a decision, they may use faulty logic, sometimes on purpose. So it's good to know about this stuff and be able to watch out for it. Okay, these two, even if the major premise is true, these two are not necessarily true. And we have an example down below here. One other thing to mention first, honorable mention, is a definition. Definitions. I'll just write it singular. Okay, so a definition is P if and only if Q. Okay, so there's a symbol. Here's an abbreviation, and we read it if and only if. All right, and that means if P then Q and if Q then P. It's both of them. That's why the arrow is going both ways. If P then Q, but also and if Q then P. Okay, so that would be something like if a parallelogram has 4 congruent sides, then it is a rhombus. If a shape is a rhombus, then it is a parallelogram with 4 congruent sides. Both are true for definitions. Okay, so now down below here, we have this with symbols. This is something I found someplace. And they were using A's and B's instead of P's and Q's. Okay, so here's your main statement, your major premise, when you start with. If A, then B. That's like if P, then Q. Okay, the inverse. Well, let's look at this example. Here's our statement. If John was born in Detroit, then John is American. Well, that's true, typically. Okay? If born in Detroit, then American. The inverse says, if not A, then not B. So if he was not born in Detroit, then he's not American. Well, we know that's false. Many Americans were not born in Detroit. So the inverse is not necessarily true. Here's the converse. If John is American, then he was born in Detroit. Again, we know a lot of Americans who are not born in Detroit. So the converse is not necessarily true. But the contrapositive is. If John is not American, then he wasn't born in Detroit. Okay, so there's your example of that. And that pretty much concludes the notes for these. Have fun.